Hi, my name is Richard Seal. I'm an independent consultant, a food technologist, and I've been working as an independent consultant since 1995. I work with a colleague of mine, Dave Baines, who is the visiting professor at Reading University, to pull together a course called Creating Thermal Process Flavours. And we run this in conjunction with the Werner Wheelock company. Delegates of the course receive instruction on how to create thermal process reaction flavours, and once they've achieved that objective, they then apply those flavours into a wide range of products such as burgers, crisp seasonings, vegan products, to test the efficacy and to test the complexity and how they function within those products. So the course is run once a year. It's a 5-day course, and we bring people together from all over the globe and work to create the most amazing flavours, which we do consistently each year. And the delegates can then take these flavours back to their countries and to their companies, and they are commercially viable from day one. Thermal reaction flavours are rooted in the Maillard reaction. To achieve complexity, depth and authenticity, it's necessary to combine a culinary approach to the basic chemistry of the Maillard reaction. This we do on the course, and as you can see, with the Maillard reaction plus the culinary ingredients, you get the wow factor, which makes these flavours commercially acceptable. In its simplest terms, the combining of reducing sugars and amino acids under a range of process conditions, pH, time, temperature, will result in the Maillard reaction, which in turn results in the creation of flavour compounds found in cooked meats. Sulfur-containing amino acids, such as cysteine and methionine, are the key to the creation of meat flavours. And it's the understanding of the interaction of the amino acids, reducing sugars and processing conditions which will result in animal-specific flavours such as beef, chicken and pork. However, these flavours at this stage can lack body, they lack depth and they lack complexity, and therefore their commercial usage is limited. The complexity is achieved through the use of a variety of ingredients, some of which are culinary in origin. Here we have the complexity wheel, and it comprises a number of elements and can be subdivided into two broad categories, industrial and culinary. And it can be achieved by using a combination of some or all of the ingredient types listed. Each will contribute to the overall acceptability of the final flavour and allow limitless creativity. The blue circles represent industrial ingredients, yeasts, HVPs, enzymically modified ingredients such as modified fats and enzymically modified offal such as liver or heart. And finally, we can include inorganic acids and salts such as lactic acid, succinic acid, potassium chloride and sodium chloride. Culinary ingredients are denoted in the red circles, and I will discuss one example in much more detail, and that example is onion. And this is exactly what happens in the domestic kitchen. Raw meat is combined with a whole range of vegetables and herbs and spices, and then roasted or fried or boiled. And the Maillard reaction occurs and the flavour compounds generated combine with key chemicals in the other ingredients to form the flavour profile of typical dishes such as Irish stew or Vietnamese pho. Onions are ubiquitous. I can't think of a single cuisine where onion doesn't figure in the savoury foods. They are the bedrock in curries and soups and casseroles and many other products besides. An onion has no aroma until the cells are damaged, and then the excitement starts. Two key enzymes are present within an onion cell. Firstly, alliinase. Alliinase is present in the onion as an odourless compound, isoalanine. And when the two combine, a highly unstable compound, 1-propanol sulfonic acid, is formed, which rapidly converts into compounds called thiosulfonates and thiosulfonate, which are precursors to the key character impact compounds of raw onion flavour. The second enzyme is LF synthase. This combines with the already created 1-propanol sulfonic acid. It converts it to propythiol S oxide, or PSO. This is the compound which is responsible for the lacrimatory effect, the effect which causes you to shed tears. And the whole process takes less than 30 seconds. It's evolved as a defense mechanism which protects the plant from predators. The three groups of compounds generated by the enzymic reactions in the onion cell all contain sulfur. That sulfur is in turn derived from the amino acids cysteine and methionine, which is present in onions. Sulfur-containing amino acids, such as cysteine and methionine, as I mentioned earlier, are key elements in the Maillard reaction, and therefore key to the creation of meat flavour compounds. The character impact compound dipropyl sulfide, which is green sulfurous onion character, is derived from cysteine. The character impact compound methylpropyl disulfide, which has an onion potato character, is derived from methionine. Onions are also rich in sugars, especially reducing sugars such as glucose and fructose. And as we saw earlier, reducing sugars are key to the Maillard reaction flavour. So we have the sulfur compounds and we have the reducing sugars all working in tandem. Research published in 2004 showed that the heating of the tear-forming compound, propanethyl S-oxide, results in the formation of a sulfur-containing compound called 3-mercapto-2-methylpentanane-1-ol. This compound has a distinct savoury character and can be described as meaty, brothy, roasted and sulphurous. So let's recap. We know that the combination of amino acids and reducing sugars, when they undergo the Maillard reaction, result in the formation of cooked meat flavour compounds. We know that the sulphur is an important element in meat flavour compounds. If we add onion, we are adding more sulphur-containing flavour compounds, and one of these is 3-mercapto-2-methylpentan-1-ol, and this will amplify the brothy, savoury character. The key character flavour compounds of fresh onion will break down in the reaction and offer more sulphur to the mix, as well as forming sulphur-based complexes which may well add to the complexity and depth and savouriness of the final flavour. We are also adding more reducing sugars, so boosting the reaction. And lastly, onion contains a significant amount of glutamic acid. It's the second highest amino acid within the onion. This adds to the umami complexity, so that we can see that adding onion really does benefit the overall flavour profile.